Chapter 1. The Listening Post. The icy fragments of Saturn's rings fade behind us, and the camera plunges into the interstellar abyss where the cold of absolute zero is the only constant. A sharp transition brings us back to earthly reality, the North Caucasus. Inside the dish of the Raytan -600 radio telescope, this cyclopean ring antenna pointed toward the zenith. A duty radio astronomer listens to the ether. For him, this night differs in no way from the thousands that came before. In his headphones, steady, maddening white noise. This isn't silence. This is space's chaotic breathing, in which a professional desperately tries to find at least one note of meaningful melody through the radio astronomer's eyes. This noise appears as an endless saw wave on spectrum analyzer monitors. He knows the nature of every spike perfectly well. Here, solar interference passed through. There, a distant quasar gives its signature, or perhaps a passing military satellite. But he is not searching for natural anomalies. His goal, a narrowband signal, a structure that blind physics cannot create, mathematical sequence, a series of prime numbers, artificial rhythm. Yet the speakers yield only static hissing from cosmic background radiation, the echo of the Big Bang that we hear but cannot read. The scale of this silence begins to truly frighten when you grasp the numbers behind it. Modern astrophysics, armed with data from orbital observatories, asserts the observable universe contains between 100 and 200 billion galaxies. These aren't just glowing spots in telescope images. These are gigantic stellar archipelagos, each a separate world with its own history and chemistry. We scan the sky expecting that in such a colossal volume of space, life simply must be boiling. Yet, in response, we get only the icy silence of vacuum. Let's narrow the search zone to our home, the Milky Way. Even here, statistics work against our solitude theory. According to astronomers' latest estimates, our galaxy alone contains between 100 and 400 billion stars. 400 billion thermonuclear reactors, warming their planetary systems. There is more than enough energy and matter here for biospheres to emerge. But when the telescope operator aims the antenna at another dense cluster in Sagittarius, he sees neither Dyson spheres nor laser beacons, only dust and hydrogen. What makes this fact even more troubling is the timescale. The universe's age is 13.8 billion years. This number is hard to grasp with human consciousness. For comparison, our species Homo sapiens has existed for just a brief moment against this eternity's backdrop. The time that has passed would have been sufficient for civilizations to be born, develop, and colonize galaxies millions of times over. First, generation stars have long since burned out, but their planets could have become cradles for minds older than us by entire geological epochs. Chapter 2. The Drake Equation and Planetary Abundance. In 1960, American astronomer Frank Drake attempted to translate this intuitive guess into strict science's language. He formulated the famous equation designed to estimate the number of active civilizations in our galaxy. This was the era of cosmic optimism. We had just begun our assault on orbit, and contact seemed inevitable. Drake's equation, accounting for star formation rate and the fraction of planets with life, predicted thousands, possibly tens of thousands of developed cultures living simultaneously with us. Since then, science has refined almost every variable in this equation. We've learned that planets exist around nearly every star. They're not rarities. We've found water and complex organics in cold interstellar clouds. we've understood that life on Earth emerged surprisingly quickly after the crust cooled. Each new fact that researchers place on the scales screams that the universe should be overflowing with voices. By all logic, radio waves should resemble a noisy metropolis where thousands of civilizations exchange data. However, the reality that confronts the rate and -600 duty officer contradicts theorists' most optimistic calculations. We've been carefully listening to the sky for over 60 years. We've scanned millions of star systems across all conceivable frequencies, from long radio waves to optical lasers. The result is always the same: absolute zero. Not one confirmed signal, not one engineered megastructure, not one hello. This glaring gap between high mathematical probability and observed fact is called the Fermi Paradox. You might object, perhaps we're just listening poorly or using primitive technology, but our modern instruments possess fantastic sensitivity. We could detect a signal as powerful as an ordinary airport radar at distances of dozens of light years. We see thermal radiation from microscopic dust grains at the solar system's edges. The issue isn't our deafness. The issue is that the sound source is absent, or it is deliberately silent. This silence transforms astronomy from star science into detective investigation. This absence of evidence becomes the main evidence itself. If in a universe nearly 14 billion years old, we see no traces of super-civilization activity, then something fundamental prevents their appearance or survival. Perhaps mind's very existence isn't a rule, but a monstrous statistical error that occurred only once. Or, even more frightening, there exists some insurmountable barrier, a great filter that ruthlessly destroys anyone trying to rise above a certain technological level. Chapter 3: The Exoplanet Revolution. We stand at the threshold of being's greatest mystery. Mathematics claims they should be here, among us, or at least in communication. But physics and direct observations give us only dead silence. Where is everyone? Why don't billions of star systems echo with life? We begin our large-scale investigation to understand whether we're the first to ask this question, or the last still alive to answer it. The silence in the ether might mean we're alone, or that they're already watching us, but don't yet want to respond. To understand this frightening silence's nature, we need to discard emotions and turn to dry facts. Until recently, in the late 20th century, our skepticism had solid foundations. We didn't know for certain whether planets existed beyond the solar system. Astronomers allowed that our sun might be a unique anomaly, the only star managing to hold around itself a retinue of rocky and gaseous spheres. If apartments don't exist, then tenants have nowhere to come from. However, the last 2 decades have turned our space conception upside down. We've experienced a true data revolution, comparable, perhaps, only to Copernicus's discovery. What began as timid theoretical assumptions became an avalanche of evidence. We've moved from questioning whether there is room for life out there to asserting there is more room than we can comprehend. One specific instrument launched into orbit in 2009 played a key role in this. I am talking about the Kepler Space Telescope. This apparatus didn't take beautiful color nebula photos for magazine covers. Its task was far more prosaic and monotonous. It spent years staring unblinkingly at the same sky section, recording the brightness of 150,000 stars simultaneously. It searched for shadows, tiny, barely noticeable drops in star brightness that occur when a planet passes between the star and telescope. This method astrophysicists call the transit method. For an observer monitoring Kepler data flows, The brightness curve graph looks like the universe's cardiogram, a smooth light line, then a sharp dip of hundredths of a percent, then recovery again. This wink means that there, hundreds of light years away, a huge celestial body blocked light from its parent star. This isn't noise in the ether or sensor error. This is gravitational reality, confirmed by millions of observation hours. The mission results proved stunning. This one telescope alone confirmed over 4,000 exoplanets' existence. Imagine the scale. Before Kepler's launch, we knew only a handful of worlds. Today, catalogs overflow with records. We discovered hot Jupiters where molten iron rains fall, and ice giants drifting in eternal darkness. But the most important discovery concerned not exotica, but worlds frighteningly similar to our own. Statistical analysis conducted based on this data paints a picture that takes any theorist's breath away. It turned out that planets aren't a rare exception, but standard star formation practice. Approximately every fifth star similar to our Sun in spectral class has an Earth-type planet in the so-called habitable zone. This is that belt where water can exist in liquid form, neither boiling nor turning to ice. Let's translate these dry percentages into concrete numbers. In our galaxy, the Milky Way, alone, there may be up to 6 billion planets similar to Earth, 6 billion potential cradles for life. This number is so large that human brain refuses to take it seriously. If we gave each person on Earth their own exoplanet, we'd still have surplus. You don't need to look through telescopes to find them. The nearest candidate sits literally on our cosmic doorstep. The distance to exoplanet Proxima Centauri b is only 4.2 light years. By galaxy standards, which spans 100,000 light years, this isn't even the next street, but the next room. We're technically already capable of sending a probe there that would reach its target within one generation's lifetime. We used to consider Earth a unique oasis in an infinite desert. Now we understand our planet is an ordinary sample in an infinite real estate catalog. 20 years ago, we didn't know if other planets existed. Today we know there are more of them in the universe than grains of sand on all Earth's beaches combined. We live not in emptiness, but in an overcrowded dormitory where life should be boiling behind every wall. This fact transforms the Fermi Paradox from philosophical puzzle into astrophysicist's nightmare. If planets were rare, space's silence would be explainable, simply nowhere to live. But now we know the stage is ready, scenery arranged, and spotlights turned on in billions of systems. We solved the first part of Drake's equation. The variable responsible for suitable planet quantity turned out enormous. But the curtain is raised, and there are no actors. This abundance traps us in a logical snare. From a purely probabilistic standpoint, among these 6 billion Earths, there should be thousands of worlds that have been developing ahead of us for millions of years. Their radio signals, their engineering constructions, the heat of their cities should be visible to our instruments. If real estate is so abundant, why are all windows dark? Chapter 4. The Search for Biosignatures. This world abundance makes silence not just strange but suspicious. We can comfort ourselves that an Earth-like planet doesn't necessarily mean a living one. Stone rotating at the right distance from a star can be sterile like Mars or toxic like Venus. Having an address doesn't guarantee having a tenant. Gravity and solid surface alone don't create DNA. We need to approach closer and peer into these worlds' very essence. To find the truth, we had to change tactics. We stopped simply counting celestial bodies and began analyzing them. Kepler was replaced by a new generation of instruments. We learned to do what seemed impossible: catch light that passed through a distant planet's atmosphere and break it into spectrum to understand what this world breathes. Light carries information. When photons from a parent star fly through an exoplanet's gas shell, atmospheric molecules absorb certain wavelengths, leaving characteristic black bands in the spectrum. This is chemical composition's barcode. If we can read this code, we'll know whether there is water, methane, oxygen. We'll know if life exists before we see it visually. We stand at knowledge's precipice. We've proved the universe built billions of homes for life. Now we must determine why these homes look abandoned. Or perhaps we simply don't know how to look through the curtains. In September 2023, the James Webb Space Telescope pointed its mirror at the K2 to 18's Wisdom. What it saw in this distant planet's spectrum made scientists' hearts stop. We're no longer guessing from coffee ground statistics. We're beginning direct hunting for biology's chemical traces. And this hunt's first results may forever change humanity's history. Chapter 5. The Ocean World. In the James Webb Space Telescope Data Analysis Laboratory, an unnatural silence reigns, broken only by server rack cooling systems humming. Here, in half, darkness lit only by monitors' cold glow, a spectroscopist sees what is hidden from the other 8 billion people. On the screen before him isn't a photograph of a distant world, not a beautiful artistic concept, but a broken graph curve. To the uninitiated, this is just noise, statistical error. But for a specialist who waited years for this telescope's launch, every peak and trough on this line is a distant reality's cry, breaking through 120 light years of emptiness. We've moved from simple galaxy population census to medical examination of its inhabitants. In the previous chapter, we established there are many planets. Now we're interested in quality, not quantity. The method we use is called transit spectroscopy. When an exoplanet passes across its parent star's disk, part of stellar light seeps through her atmosphere is thin layer. The gases composing this air work as filters, greedily absorbing photons of certain energies. The light reaching telescope mirrors is no longer pure white stellar noise. It bears scars, dark absorption lines carved by alien atmosphere molecules. This is the spectral fingerprint, unique chemical barcode. By deciphering it, we can confidently say what air smells like on a planet we'll never see with our eyes. This method brought sensation in September 2023 that forced astrophysicists to reconsider the boundaries of possibility. Research object: exoplanet K2 to 18b. This is a world with no analog in the solar system. It is 8 times more massive than Earth, classifying it as a sub-Neptune. It orbits a red dwarf in the so-called Goldilocks zone, the narrow orbital ring where temperature allows water to remain liquid. Before James Webb's launch, they could only guess about this giant's nature. But new spectral analysis data showed distinct, unmistakable peaks, indicating methane and carbon dioxide presence. These two gases' presence in such proportions isn't just chemistry, it is planetary, scale geology. Ammonia's absence in the spectrum, combined with methane and carbon dioxide, allowed scientists to hypothesize about a global water ocean covering K2 to 18b's entire surface. Astronomers call such worlds Haitian worlds, from the merger of hydrogen and ocean. This is a completely new class of habitable worlds we didn't even suspect existed. Through our laboratory specialists' eyes, we see dry numbers acquiring form. The data paints a world picture where under a dense hydrogen, rich atmosphere spreads a boundless ocean. Water there might be hot, close to boiling, but pressure keeps it liquid. A red sun hanging in the sky would paint waves dark blood color. This isn't a resort paradise, but it is a thermodynamic system possessing all ingredients for launching biological reactors. However, among methane and carbon dioxide peaks on the graph, there is a weak, barely noticeable signal causing researchers a mixture of delight and professional fear. The spectrometer caught a hint of dimethyl sulfide presence. This is a complex organic compound consisting of sulfur, carbon, and hydrogen. On Earth, it doesn't arise from volcanic activity or geological processes. Only living organisms produce it. If you've ever felt the characteristic sea smell while standing on the shore, you are breathing exactly dimethyl sulfide. On our planet, marine phytoplankton and certain algae species are the main factories producing this gas. Discovering this substance in a distant water world's atmosphere is a potential biosignature, the strongest evidence we've ever found beyond the solar system. This isn't just conditions for life anymore. This is possibly its life activity products. But science is the art of doubt. The spectroscopist knows premature joy can destroy careers and discredit entire research directions. K2 to 18B's dimethyl sulfide signal remains weak and requires confirmation. We're working at instrument sensitivity limits, where the telescope's own electronic noise can masquerade as the greatest discovery in history. The complexity also lies in trying to analyze a tiny planet's light against its parent star's blinding glow background. This is like trying to make out a mosquito flying against a stadium floodlight background while being on another continent and determining whether it drank blood by its wings' color. The precision James Webb's mirror compares to seeing a bumblebee's thermal signature from Earth to moon distance. Nevertheless, the very fact we're having this discussion is revolutionary. 20 years ago, we didn't know if other planets existed at all. 10 years ago, we debated how to find them. Today, we debate whether the ocean on a planet 120 light years away smells of bacterial life. Activity products. This progress has been dizzying. We've moved from telescope astronomy to molecular biology astronomy. Cake 2 to 18B's ocean world hypothesis opens a frightening prospect before us. If dimethyl sulfide is indeed present, this means life isn't Earth's unique miracle, but chemistry's inevitable consequence. As soon as water and energy appear, matter begins organizing into complex structures. The universe might be literally saturated with life, like an old damp wall saturated with mold. But here lies a catch we must consider. Biosignature isn't an alien photograph, it is circumstantial evidence. Methane can be produced by geology. Dimethyl sulfide might have unknown abiotic sources operating under high pressures of hydrogen atmospheres. We're looking at reality, cast shadows, and trying to reconstruct the object from this shadow. The laboratory spectroscopist understands the graph on his screen is either proof of our cosmic brotherhood or evidence of our complete incompetence in exoplanet chemistry. Moreover, even if this ocean teems with phytoplankton, this says nothing about intelligence. Bacteria ruled Earth for billions of years without building a single city or asking a single question. Life presence and conversation partner presence are two different universes. We might find billions of planets covered with slime, algae, and fungi, but remain in intellectual solitude. Biosignature confirms biology, but not civilization. Chapter 6: Mars and the Limits of Life. even if spectral analysis of distant worlds gives us only indirect evidence. In our own solar system, we can touch truth. Literally, chemical markers we found hundreds of light years away are just echoes. But here, right next to us, lie bodies that can tell a frightening story about how often life tries to emerge and how often it loses this battle. To understand cosmic silence's tragedy, look at what is only 225 million kilometers away. 4 billion years ago, Mars wasn't the rusty desert we see in photographs. If you'd found yourself there at that time, you would have heard surf noise and seen heavy rain clouds in the sky. This was Earth's twin planet, possessing dense atmosphere and deep oceans. But then the planetary mechanism malfunctioned. Mars's core cooled too quickly. The magnetic field serving as shield disappeared, and merciless solar wind stripped the atmosphere like peel from fruit. Water evaporated into space, or went deep into soil, turning into permafrost. The flourishing world died without managing to give birth to anything more complex than bacteria. This is the first part of the answer to, where is everyone? Perhaps the universe is full of ruins, not civilizations. Right now, the Perseverance rover crawls across a dried lake bottom in Jezero crater. Its cameras scan sedimentary rock layers that were a stormy river delta 3.5 billion years ago. The rover seeks not little green men, but fossilized slime, stromatolites. If it finds them, this will prove life is an ordinary phenomenon arising wherever water exists. However, finding Martian bacteria will become not so much triumph as ominous omen. If life originated on two neighboring planets almost simultaneously, but died on one while reaching internet creation on the other, this means the very fact of life's origin guarantees nothing. Mars is a monument to how easily the universe erases its experiments. But Mars is the past. In the solar system are places where life might be hiding right now. This very second, we've grown accustomed to seeking habitable worlds in the Goldilocks zone, at comfortable distance from the star. But nature apparently found a workaround. In the cold darkness of outer planets exist oases that don't need sunlight to support biological activity. Look at Europa, Jupiter's moon. Outside, it is a dead ice ball crisscrossed with cracks from the gas giant's monstrous gravity. But these cracks breathe. Data shows that under an ice shield, tens of kilometers thick, hides a global ocean of liquid water. Its depth reaches 100 kilometers, containing twice as much water as all Earth's oceans combined. There, in absolute darkness, the only energy source isn't the sun, but geothermal springs on the bottom black smokers. On Earth, life boils around such springs. Giant worms, crabs, mollusks, they live through chemosynthesis, processing chemical substances thrown from the planet's depths. If this is possible here, why is it impossible on Europa? Even more intriguing data came from the Cassini probe that studied Saturn's system, flying through geyser plumes shooting from Enceladus's icy crust. The apparatus's analyzers detected not just water but complex organic molecules. This is direct injection of life's building blocks into open space. Enceladus literally screams to us, "I'm alive." But here we encounter a conceptual trap called survivor bias. We assume if there is water and organics somewhere, intelligence will inevitably appear. However, conditions on Europa or Enceladus are perfect prisons. Imagine beings living under a 20-kilometer layer of ice. They never saw stars. They have no access to open fire, without which metallurgy is impossible. They might be intelligent as dolphins, but they'll never build radio telescopes. This leads us to the rare Earth hypothesis. Perhaps life itself is cosmic mold that inevitably appears in the universe's damp corners. But complex technological life requires unique circumstances that perhaps occurred only once. We seek Mine Brothers and will find only endless oceans with jellyfish and rocks covered with moss. Think about how many factors must coincide. Earth got incredibly lucky with the moon. Its gravity stabilizes our planet's rotation axis, preventing chaotic climate changes. Without the moon, seasons on Earth would change catastrophically quickly, not giving complex organisms adaptation time. Mars has no such stabilization, Venus either. We have a powerful magnetic field that has deflected solar radiation for billions of years. Mars's generator broke. We have plate tectonics, regulating the carbon cycle, maintaining atmospheric temperature. This is the finest tuning of the planetary piano. Remove just one key, and evolution's music turns into extinction cacophony. We look at the starry sky and ask, where is everyone? But perhaps the answer lies not in space, but in biology. The universe might be overpopulated, but its inhabitants are either trapped under ice or too primitive to ask questions. We might be the only ship in an ocean whose crew can manage sails, while the rest drift as plankton. Chapter 7. The Great Filter. This is a frightening prospect. It means the great filter theorists discuss isn't ahead of us, but behind us. We've already won the lottery with one, in 1 trillion odds, traveling from bacteria to humans. But if we really are the last living beings capable of self-awareness, then our loneliness becomes not just fact, but the heaviest burden of responsibility before a dead universe. If we admit simple life is commonplace, hidden under neighboring planets' ice crust, then why don't we see those who manage to climb out of their cradle? An evolution theorist looking at nighttime megacity lights outside his office window sees not reason's triumph, but statistical anomaly bordering on miracle. His desk is covered with printouts of stochastic models, and each screams about one thing. The path from bacteria to radio telescope builders isn't a straight road, but a minefield we've grown accustomed to thinking evolution is a ladder leading strictly upward to intelligence. This is perhaps the most dangerous delusion in our culture. Looking at life development simulation on a monitor, we see that nature doesn't strive to create brains. Survival is enough for her. The universe plays dice, and the odds of rolling the intelligence combination might be 1 in 1 trillion. That we're here isn't natural law, but classic survivor bias. Let's look at Earth's chronology without anthropocentrism's rose-colored glasses. The geological record shows primitive life appeared on our planet almost instantly after crust cooling about 4 billion years ago. This fact is often used as argument favoring widespread universe life. If it arose so quickly, then abiogenesis, the transition from chemistry to biology, happens easily. But then something strange occurred that biologists call the boring billion. For almost 2 billion years, half of all Earth history, evolution marked time. The planet was populated exclusively by prokaryotes, primitive single-celled organisms without nuclei. Imagine an ocean covered with slime where nothing changes for entire eternities. If an alien probe had flown past Earth during that period, it would have detected life but considered the planet a biological dead end. Here, in this temporal abyss, hides perhaps the first and most terrible great filter, the transition from simple cells to complex organisms, eukaryotes. This is an event with vanishingly small probability. On the laboratory computer screen, we see billions of virtual DNA attempts to assemble into complex structure. Each time the model produces error. Complexity requires colossal energy expenditures that simple bacteria simply cannot afford. In our planet's history, the key event allowing this vicious circle break happened only once. This is symbiogenesis. One predatory bacterium swallowed another, but instead of digesting it, entered alliance. The swallowed cell became mitochondria, the energy station that gave multicellular life existence possibility. Without this accidental, unique merger, Earth would have remained a microbe planet. Think about this coincidence's scale. Over 4.5 billion years in a gigantic chemical reactor planet. Sized, such successful merger took hold only once. Not twice, not thrice. This makes our theorists look at graphs with alarm. If this event is so rare, then the Milky Way might be filled with planets stuck at bacterial slime stage, unable to take the next step even in 10 billion years. Even if nature overcomes single-cell barriers, an even narrower bottleneck awaits. Mind development is energetically disadvantageous strategy. Human brain consumes 20% of body energy, while comprising only 2% of its mass. From Darwinian selection perspective, this is impermissible luxury. For survival, sharp claws or armor are far more effective than ability to solve differential equations. Biological diversity statistics confirm this pessimistic conclusion. Throughout Earth's history, about 50 billion species of living creatures existed. 50 billion evolution experiments. Only one of them, Homo sapiens, created technological civilization. If mind were evolution's inevitable outcome, we'd see its manifestation everywhere. Like we see eyes or wings that nature invented independently dozens of times. Moreover, we still don't understand how life's very process starts, despite 70 years of intense experiments beginning with Miller-Urey experiments. Scientists haven't managed to reproduce complete abiogenesis in laboratory conditions. We've learned to synthesize amino acids but not create self-replicating molecules capable of Darwinian evolution. Test tube's silence frightens no less than radiotelescope's silence. Staring at data, the theorist realizes our civilization might result from incredible coincidences whose probability approaches statistical zero. We won a lottery requiring guessing 100 numbers in a row. First, stable star, then planet in habitable zone, then RNA emergence, then that very symbiogenesis, and finally survival of species with hypertrophied brain. This concept overturns our Fermi Paradox perception. We ask where everyone is, assuming the universe is a civilization production factory. But perhaps it is more like a desert where life flares rarely and quickly extinguishes, without managing to recognize itself. The great filter isn't a wall we'll crash into in the future. It is sieves we've already miraculously slipped through in distant past. If this hypothesis is true, then we're the loneliest beings in creation. We're reason's only firekeepers within millions of light years radius. All other planets Kepler finds by hundreds might be either sterile stones or oceans filled with stupid happy jellyfish who'd never think to build spaceships. Chapter 8. The Hostile Universe. But even if we assume we're wrong and life breaks through with enviable persistence, evolution doesn't happen in vacuum. It proceeds against a cruel, radioactive, unstable universe background. Even if a species gained intelligence, it might simply lack time to use it. The galaxy isn't a cozy garden, but a zone of constant high-energy physics combat. While cells on planetary surface Try assembling into complex structures. Invisible killers already fly toward them from space depths. External environment, which we'll discuss next, might be the executioner cutting evolution experiments, short long before they bear fruit. Modern astrophysics introduces galactic habitable zone concept. This is a narrow ring where life has at least theoretical survival chance. Closer to galaxy center, star density is so high that night sky would shine brighter than our day. But radiation levels would sterilize any organics instantly. The supermassive black hole in the core and frequent supernovae outbursts turn central regions into dead zones where complex molecules decompose faster than they can form. However, galaxy periphery also doesn't suit life. There are too few heavy elements, metals necessary for rocky planet formation. Gas giants are possible there, but creating second Earth on Milky Way's outskirts is simply impossible for lack of materials. We're in privileged position, in quiet harbor between Orion and Perseus arms. But even this harbor doesn't stand still. Our solar system revolves around galaxy center at 220 km phase-second speed. One complete revolution, or so-called galactic year, takes 220 million Earth years. During this time, solar system periodically dives into galaxy's spiral arms, areas of increased gas and dust density. Here new massive stars are born that live brightly but briefly, dying by exploding as supernovae. Each such arm crossing increases risk of finding ourselves in blast wave damage zone. But the most terrible threat comes without warning. Gamma ray bursts are the most powerful electromagnetic events in the universe since the Big Bang. When a massive star collapses, it can release a narrowly directed energy beam. If a planet finds itself in this beam's path, distance of even several thousand light years won't save it. Gamma radiation of such intensity doesn't just kill living things. It destroys planetary protection. Modeling shows a gamma ray burst directed at Earth would instantly destroy the ozone layer. Without this shield, solar ultraviolet would freely reach surface, causing mass phytoplankton death in oceans and DNA destruction in terrestrial organisms. Atmosphere would turn into toxic smog of nitrogen oxides. Perhaps exactly such event caused the Ordovician Silurian extinction 440 million years ago. You might object, our sun is stable, and we're far from dangerous giants. But let's look at exoplanet statistics we analyzed in the second chapter. 75% of all Milky Way stars are red dwarfs. Around them we most often find rocky planets. It was long believed their incredible longevity made them ideal civilization incubators. But recent data destroys this hope. Red dwarfs are colder than the sun, so the habitable zone sits very close to the star, closer than Mercury to our sun. At such distance, monstrous tidal forces act. The planet finds itself in gravitational capture. It is always turned toward star with one side. On one hemisphere, eternal scorching day. On the other, icy night. Life is possible only in narrow twilight zone, on light, dark boundary under eternal hurricane conditions. But red dwarfs' main problem is their unstable character. These stars are prone to powerful outbursts. Telescope data shows Proxima Centauri, our nearest neighbor, can increase brightness thousandfold in seconds. Such flares accompany coronal mass ejections that literally blow away nearby planets' atmospheres, leaving only bare irradiated stone. Astrophysicists call this the red sky paradox. Most universe planets revolve around such stars, but conditions there resemble radiation chambers rather than life cradles. If 90% of potentially habitable worlds undergo regular sterilization by X-ray and ultraviolet radiation, then Fermi's paradox gets frighteningly simple explanation. Life might originate often, but burns before managing to invent radio. Chapter 9. The Dyson Sphere Hunt. If we admit some civilizations managed to survive cosmic bombardment and overcome vulnerability stages we discussed earlier, they face new, no less fundamental problem. Survival requires expansion, and expansion is impossible without colossal energy expenditures. In this chapter, we stop seeking biological slime and start seeking engineers capable of redrawing stellar maps. We proceed from simple logic. Any developed technology leaves traces. The higher the development level, the larger scale construction debris civilization dumps into space. We no longer seek timid methane molecules in atmospheres. We seek those who turned their star systems into galactic-scale industrial zones. In the spectroscopy laboratory reigns darkness lit only by monitors' cold glow. The spectroscopist sees the universe not as star scattering, but as infinite thermodynamic data flow. For him, physics laws are chief informants, and the chief among them is thermodynamics. Second law, stating, impossible to do useful work without releasing heat. This rule works for both car engines and galactic empires. Any energy consumption inevitably creates waste heat radiation. Soviet astrophysicist Nikolai Kardashev proposed in 1964 classifying civilizations exactly by this sign, by energy amounts they can harness. Kardashev divided potential neighbors into 3 types. We're interested in type 2. Civilizations capable of using all their star's energy. We're talking about monstrous powers of about 4 Fe 10 Fe watts. For comparison, all humanity today produces 1 trillion times less energy, not even approaching type I civilization status. To collect such energy volume, it is insufficient to simply cover the planet with solar panels. You must surround the star itself with dense shell of satellites or stations. This hypothetical megastructure, known as Dyson sphere, should intercept starlight, convert it to work, and radiate remainders as infrared heat. This is exactly the heat we seek. Hiding type 2 civilization is as difficult as hiding burning campfire. In dark forest, even if they close their star with impenetrable shield, the shield itself will heat up and begin glowing in infrared range. For orbital telescope, such object would look not like bright star, but like dark hot ghost. Specialists working with WISE infrared telescope data conducted perhaps the most ambitious cosmic population census in history. In the GLISE survey framework, they scanned 100,000 galaxies' radiation. The goal was simple: find galaxies that shine in infrared too brightly for ordinary stellar clusters. These analysis results affect optimism like icy shower. Of 100,000 checked galaxies, not one demonstrated obvious signs of colonization by Type 3 civilization using billions of stars' energy. The universe looks frighteningly natural. We see neither rebuilt galaxies nor extinct sectors nor stellar engineering traces. However, absence of gods ruling galaxies doesn't mean absence of civilizations in separate star systems. We narrow search. Astronomers' attention attracts local anomalies impossible to explain with standard planet formation models. One such anomaly made scientific community hold its breath. Star Kick 8,462,852, better known as Tabby's star, sits in Cygnus constellation, 1,500 light-years away. In 2015, brightness analysis showed something that fit no framework. Ordinary planet-passing star disk reduces brightness by 1% maximum. Tabby's star brightness fell chaotically, and these dips reached incredible 22%. Imagine watching floodlight and someone periodically covering quarter of it with huge irregular-shaped plywood sheet. Neither comet swarm nor cosmic dust cloud could give such sharp, deep eclipse pattern. At that moment, even most conservative skeptics admitted thought. We're seeing Dyson sphere construction. Perhaps we observe giant panels half our solar system size mounting in orbit, blocking starlight. This would be first direct visual contact with alien intelligence technology. But science demands reproducibility and exclusion of all natural factors. Subsequent observations showed Tabby's star eclipses have different depths in different spectrum colors. This is characteristic of small dust that scatters blue light stronger than red. Solid objects like solar panels would block all light equally. The megastructure hypothesis wasn't definitively disproven, but moved to unlikely category. Most probably, we observe exomoon destruction or consequences of monstrous planet collision that created dust cloud. Again, nature proved more inventive than our boldest fantasies, leaving us alone with silent thermodynamic background. We examined galaxy through thermal imaging and found no cities. We sought great construction traces, but found only dust. Does this mean they don't exist? Or perhaps our ideas about their energetics are as naive as Neanderthal ideas about nuclear reactors. Maybe they learned to be not only invisible, but cold. Chapter 10. The WOW signal and radio silence. If we don't see their heat and don't see their engineering wonders, we have one last, most classic communication channel. Perhaps they don't rebuild stars, but simply, like us, try shouting to neighbors. In the next chapter, we turn to radio ether listening history, where among white noise once sounded something resembling hello. For radio astronomer on duty in apparatus room, space sounds not like music, but like static ocean. His task: find order in this chaos. Artificial signal should possess properties impossible for natural phenomena: narrow frequency band, mathematical modulation, or repeatability. Oscillograph screens usually show only white noise, dancing, cosmic radiation, echo, and electron thermal movement. But history knows one case when this noise suddenly folded into meaningful word. The 15th of August, 1977, Ohio State's Big Ear Radio Telescope conducted routine sky scanning. In data printouts analyzed by astronomer Jerry Eman, appeared symbol sequence exceeding any statistical error framework. 6 signs, 6 equage 5, designated radio emission intensity, burst 30 times more powerful than background. Eman, stunned by what he saw, circled these figures with a red pen and wrote in margins one word: wow. This signal perfectly matched artificial transmission profile. It sounded at 1,420 MHz frequency. Neutral hydrogen line physicists consider universal interstellar communication standard. But most intriguing was its duration, exactly 72 seconds. This isn't random number. This is exactly the time rotating Earth needed to carry fixed telescope beam through signal source on celestial sphere. This meant source sat deep in space, in Sagittarius constellation. However, science requires repeatability. Here begins WOW signal tragedy. Since then, we've aimed antennas at this point thousands of times, used equipment whose sensitivity exceeds 70s technology by orders of magnitude. But ether remained silent. Signal disappeared, as if whoever sent it turned off transmitter or turned away directed beam. This bred skepticism. Was this reason's voice? Or did we catch Earth signal reflection from space debris? There is still no answer. Today, we no longer rely on random printouts. Project Breakthrough Listen uses modern observatories' power to scan million nearest stars. China operates Fast Telescope, Sky Eye half-kilometer diameter. Its dish is so huge, it could catch mobile phone signal in Mars orbit. This giant listens to sky round the clock, processing petabytes of data. In the 2010s, it and its analogs worldwide began recording new phenomenon. Astronomers called them fast radio bursts or AFBs. These are monstrous power pulses lasting just milliseconds. During this instant, unknown source throws into space as much energy as our sun produces over 3 continuous burning days. They come from other galaxies, overcoming billions of light years. Initially, their characteristics seemed too perfect to be natural. We seem to finally find that very galactic communication network. Especially suspicious looked repeating burst FROB 121,102. It hit one point with frightening regularity, ignoring chaotic nature of cosmic explosions. Theorists advanced bold hypothesis. Perhaps these aren't communication signals, but energy leaks from gigantic acceleration lasers, pushing light sails of interstellar ships. We began believing we heard Type II civilization engine noise. But in April 2020, this hope crashed against high-energy physics laws. For first time, fast radio burst source was recorded inside our own Milky Way galaxy. This allowed aiming optical and X-ray telescopes at it simultaneously. We saw perpetrator face to face. It turned out to be not alien transmitter or laser installation, but magnetar, exotic neutron star with phenomenally strong magnetic field. Magnetar is dead star with atomic nucleus density, compressed to large city size. Its magnetic field is trillions times more powerful than Earth's. When such stars' crust cracks from starquake, colossal energy release occurs that we mistook for artificial signal. Again, universe deceived us. What looked like technology proved just extreme astrophysics. This discovery was sobering blow. First in 60s, we mistook pulsars for alien beacons, calling them LGM. Little green men. Now we aired with fast radio bursts. Nevertheless, our search volume remains negligibly small. Astronomer Jill Tarter compared our efforts to trying to understand whether fish exist in ocean by scooping one glass of water from it. We've investigated only tiny radio range fraction and negligible sky sector. We seek signals resembling our own, forgetting that alien civilization technologies might advance millions of years using data transmission methods we don't even suspect. But there are more frightening silence interpretations. Equations show Earth radio emission grows weaker yearly. We transition to fiber optics, cable broadcasting, directed digital communication. We stop radiating to space. If this is natural development stage for any technology, then radio contact window opens very briefly, just 1-200 years. Perhaps galaxy is full of civilizations, but all already fell silent, entering digital calm. Or silence reason is far more tragic. We don't hear them, not because we have poor receivers or because they use quantum communication. Perhaps radio signals stop not due to progress, but catastrophe. What if ether silence is graveyard silence? Chapter 11. The Great Filter Theory. What if technology development inevitably triggers self-destruction mechanism, firing before civilization manages to colonize even neighboring star? We approach Fermi Paradox's darkest explanation. If life arises frequently but we see and hear no one, then some barrier exists that almost no one can overcome. You might think radio ether silence we discussed earlier is just technical problem. Frequency tuning question or insufficient antenna sensitivity. But for evolution theorists analyzing data in flickering monitors' light, this signal absence looks not like communication failure, but final diagnosis. Sudden radio transmission cessation. We can theoretically detect from distant star frightens much more than white noise. Look at this model built on sociobiology pessimistic forecasts. Before you lies planet that, until recently glowed with city night lights, but now plunges into darkness. Orbital satellite network turned into useless scrap metal atmosphere, saturated with isotopes not existing in wild nature. This isn't natural catastrophe. This is development's natural outcome when technology outpaces creator's wisdom. Here great filter frightening concept enters our investigation, formulated by economist Robin Hanson in 1996. Its essence is simple and merciless. On path from non-living matter to galaxy colonization exists barrier almost impossible to overcome. If we find no neighbors, this barrier works with 100% efficiency, filtering civilizations one after another. Our evolution theorist sees not just hypothesis, but statistical trap. Look at technological progress graph. These are exponentials shooting vertically upward. We traveled from stone axe to atom, splitting in cosmic scale instant. But biological evolution of our brain, responsible for aggression and territorial instincts, remained at Pleistocene level. This gap is called technological singularity paradox. We created tools capable of destroying planets, but entrusted their control to primate instincts. If this scenario is universal for any intelligent life, then technological civilization lifespan measures not in millions of years, but mere centuries. Contact window opens when civilization invents radio and slams shut when it invents mass destruction weapons. This finale traces remain long. Plutonium, -239.5. Life is 24,100 years. If we disappeared today, this isotope would remain detectable marker of our stupidity for tens of thousands of years. For external observer, our planet would become not reason's cradle, but radioactive mausoleum warning others. Don't enter. Here experiment went out of control. But nuclear winter is just one scenario. Climate modeling laboratory scientists consider another filter variant, ecological collapse. Energy consumption growth necessary for space exit inevitably heats planetary system. This is thermodynamic dead end. Civilization burns its cradle resources faster than managing to build evacuation arc. It suffocates in its own life. Activity products. Look at this hypothetical planet surface reconstruction. Megacity ruins swallowed by jungles look like ambition monument. Game theory suggests competition for exhaustible resources on closed sphere always leads to zero-sum conflict. On galactic scale, this means mind is self-limiting phenomenon. It flares bright like match and extinguishes just as quickly, not managing to light signal fire for neighbors. For us, this question has not theoretical but existential significance. Great Filter's main mystery lies in its location relative to us. If filter is life or mind emergence complexity, then we're lucky. We already passed it. We won cosmic lottery. But if we see only dead worlds around while life originates easily, then great filter awaits ahead. This realization changes universe silence perception. Space silence stops being neutral fact. It becomes harbinger. It tells us, every one who reached your development stage perished. We walk through cemetery, hoping we're first who can pass through technological youth minefield without stepping on self-destruction detonator. Chapter 12. The Dark Forest Hypothesis. Even if we admit most civilizations perish, statistics on large numbers should allow exceptions. Someone should have survived. Someone should have broken through. If at least one civilization overcame self-destruction stage, it would have billions of years at disposal. Its expansion should have become unstoppable. It should have sent automatic probes to every galaxy corner, including our solar system. Here we encounter another contradiction. If they survived, where are their machines? Even if biological bodies are fragile and planet-bound, their technologies can live forever. Robot scouts don't fear radiation, need no air, and don't wage nuclear wars. In the next chapter, we examine a scenario where galaxies should be flooded with self-reproducing machines and try understanding why our yard remains suspiciously clean. Even if civilizations perish in nuclear war flames or suffocate in ecological traps, their technology needn't die with them. This is fundamental difference between fragile biology and cold silicon, or exotic alloy logic. Biological species need water, atmosphere, stable climate. Autonomous probe needs only matter for repair and star energy. Mid-20th century mathematician John von Neumann described self-reproducing automata concept. These are machines capable of extracting resources from asteroids or planets, creating exact copies and sending them to neighboring stars. On such probe reaches new system. It repeats cycle. 1 becomes 2, 2 become 4, 4 become 8. This isn't science fiction. It is exponential growth, inexorable force we observe even in Earth bacteria. Mathematical modeling of this process gives stunning results. Even if such probes moved at conservative 1% light speed, about 3,000 km phase second, they'd need negligibly small galactic scale time for entire galaxy colonization. We're talking about 10 to 100 million year period. This is instant in universe history, whose age is 13.8 billion years. Look at this figure soberly. Our galaxy has existed over 10 billion years. If at least one civilization launched von Neumann program in distant past, their probes should have already visited every Milky Way star system, not once but thousands of times. They should be everywhere: asteroid belt, Mars orbit, Saturn rings. We should see their matter processing activity, but telescopes record only dead stone and ice. We call this absence factor. If technological development is natural process, then Milky Way should be saturated with machines, like forests saturated with insects. However, when astronomers discovered first interstellar object flying through solar system in October 2017, scientific world froze. Asteroid Oumuamua, meaning scout in Hawaiian, behaved as if challenging celestial mechanics. This object had strange, unnaturally elongated cigar shape and moved on hyperbolic trajectory, indicating origin outside our system. But most disturbing began later. Moving away from Sun, Oumuamua accelerated. This non-gravitational acceleration is impossible to explain by planetary attraction. Usually comets behave this way, ejecting gas. But around Oumuamua, no dust, tail, or substance evaporation signs were detected. Several astrophysicists, including Harvard's Professor Loeb, advanced bold hypotheses. Acceleration might be caused by solar light pressure on artificial solar sail. If we assume Oumuamua is drifting, possibly broken probe of another civilization, many oddities find explanation. However, scientific consensus remains skeptical. More detailed analysis proposed hydrogen ice ejection model invisible to telescopes. Nevertheless, Oumuamua case showed how unprepared we are for artifact encounters. But if this object was just stone, where are real probes? We've searched not only in deep space, but under our noses. Lagrange points, gravitational equilibrium zones between Earth and Moon, or Earth and Sunday, are ideal parking places for observation stations that can hang there millions of years without fuel consumption. Lagrange point scanning in optical and radio ranges revealed nothing artificial. We studied Moon with tens of centimeters resolution thanks to L-orbital probe. On its surface, lacking erosion, any metal object left 100 million years ago would gleam like new. But we see only craters, dust, and traces of our own modules left half-century ago. Our system is virgin clean. Here Copernican principle comes into force, stating Earth occupies no unique universe place. If we humans already today design probes for Alpha Centauri flight, such as Breakthrough Starshot project, it is extremely presumptuous, assuming we're first to conceive this idea. Others had billions-year advantage. Their machine's absence tells us something fundamental and frightening about reality structure. To explain von Neumann probe's absence, we must assume none of billions potential civilizations over billions of years wanted to explore space. Or there exists some universal law, physical or sociological, strictly prohibiting self-reproducing machine creation. But such prohibition seems incredible for so many different cultures. Chapter 13. Dark Forest. There is darker interpretation. Perhaps probes exist, but they're not designed for contact. Science fiction has berserker concept. Machines programmed to destroy any emerging competition. But if such cleaners patrolled galaxy, we wouldn't discuss this question. Earth life would have been destroyed at Proterozoic stage. So aggressive patrol scenario seems unlikely, at least in our Orion arm sector. This absence of galactic noise and mechanical presence forces us to consider hypothesis frightening in its rationality. What if reason we don't see probes isn't that they cannot be created, but that their launch is death sentence? Perhaps universe has rule written in blood of perished worlds. Don't stick out. Any activity, any probe, any signal reveals your location to predators who don't negotiate. We approach Fermi Paradox's most sinister explanation, known as dark forest hypothesis. In this model, universe isn't emptiness, but night thicket full of hunters, where only those who can hold breath survive. Dark forest metaphor proposed by Chinese science fiction writer Liu Cixin today acquires strict sociological formulation. Imagine night thicket, where every rustle might mean death. Here are hunters and victims. The only survival rule for anyone who lit reason fire: immediately extinguish it and hide. Dark forest basis is cosmic sociology's first axiom. Survival is civilization's primary need, but universe resources, despite its size, are finite. This creates inevitable conflict. Our theorist introduces variable, making war inevitable. Distant when hundreds of light years separate two civilizations. Real-time communication is impossible. What game theory calls suspicion chain arises. Earth observer cannot know aliens' true intentions. Even if we assume they're good, They cannot know what we think about them. More importantly, they don't know what we think about what they think about us. This mathematical recursion leads to dead end. Under uncertainty, safest strategy for any civilization is striking first, before potential opponent does. Situation is worsened by technological explosion concept. For cosmic observer, time flows differently. Civilization at Stone Age or primitive radio level today might tomorrow, by galactic standards, become godlike entity, threatening senior races' very existence. So for developed civilization, there is no concept of harmless neighbor. Any life is growing threat rationally eliminated in embryo. Theorist sees simulation screen, where red dots disappear one by one. This isn't malice or hatred. This is cold utilitarian logic. Hunter shoots, not from cruelty, but because forest is dark. Anyone who revealed position violated main safety rule. In this paradigm, universe silence isn't life absence, but proof of its high intelligence. Only those who learned silence survived. Discovery fear explains megastructures absence we sought in 7th chapter. Dyson's sphere shields star but turns it into giant infrared beacon visible across galaxy. Building such objects in dark forest equals lighting giant campfire in enemy territory center. Intelligent species consciously limit energy consumption or mask it to avoid becoming targets. If this hypothesis is true, humanity's position looks terrifyingly naive. We're that very child walking through night forest, loudly singing songs and waving flashlight. We send radio signals. We scan sky with radars. We change atmospheric chemical composition so it is visible across parsecs. From galactic security standpoint, Earth behaves insanely. Our theorist reviews METI project archives, active message transmission to extraterrestrial civilizations. In 1974, we sent message from Arecibo to globular cluster M13. Later, we sent Beatles songs to Polaris and complete DNA maps to other sectors. We literally mailed our coordinates and biology descriptions to all available addresses, inviting guests. Active search proponents argued developed civilization should be humane, but on theorists' desk lie examples from Earth history. Meetings of two civilizations with different technological levels on Earth always, without single exception, ended in catastrophe for less developed side. Incas and Aztecs didn't receive knowledge encyclopedia from conquistadors. They got smallpox and destruction. There is no reason assuming different laws operate in space. Special horror is evoked by cleansing concept. Super civilization attack wouldn't look like flying saucer fleet invasion. Heroism could repel. This would be strike by physics laws. Accelerating small projectile to near light speed or directed space metric collapse. We wouldn't even understand we were attacked. Sunday would simply flare brighter or atmosphere instantly disappear. For Hunter, this is as routine as stepping on ant. Looking at starry sky, evolution theorist feels perception of this beauty changing. Silence no longer soothes. Now every dark sky section seems hiding. Observer. Those who screamed are dead. Those alive stay silent. Only Earth continues. Reckless radio broadcast, transmitting news, talk shows, and military radars into deep space, hoping no one's there. This theory elegantly solves Fermi Paradox, but solution price is our paranoia. If universe truly is dark forest, then first contact will be last event in our history. We won't hear greetings. We'll just see light go out. Chapter 14. The Zoo Hypothesis and Simulation. This sudden perspective change transforms our investigation genre from cosmic horror, where we hide from dark forest predators, to sterile laboratory whiteness. If dark forest hypothesis claims we weren't destroyed only because not yet noticed, then next theory offers even more disturbing variant. We were noticed, classified, and placed under glass dome. In 1973, astronomer John Ball formulated so-called zoo hypothesis. It assumes extraterrestrial civilizations not only exist, but control every galaxy sector like national park wardens. According to this concept, Earth is declared nature preserve where interference is strictly prohibited. Great silence isn't life absence, but perfectly observed quiet regime necessary for experiment purity over us. Logic here is impeccable. Remember how modern anthropologists treat uncontacted tribes on Andaman Islands or Amazon forests. We observe them from satellites, but don't land helicopters to avoid destroying their fragile culture and introducing diseases. For civilization millions of years ahead, humanity with its wars and primitive radio might look exactly like such tribe that is too early to know big world truth. However, in 21st century, this idea mutated into something much more radical. With our own computational power development, physicists and philosophers began asking, why build physical zoo when you can create digital one? Swedish philosopher Nick Bostrom proposed simulation argument that mathematically proves frightening probability that all our observable universe isn't base reality, but program code. Bostrom's argument builds on simple statistics. If developed civilization can create detailed computer simulations of its ancestors' lives, and if many such civilizations arise over time, then virtual people inside simulation will exceed real biological organisms by billions. Consequently, probability that exactly you are now in base reality statistically approaches zero. In this model, Fermi Paradox solves instantly. We don't see aliens for same reason video game character cannot meet player sitting at keyboard. Other civilizations simply aren't coded into our server program. Universe seems empty because simulation is calculated for only one observer, humanity, or even one specific subject. Most amazing modern physics begins finding circumstantial evidence confirming this insane guess. If we look at nature's fundamental constants through programmer eyes, they begin suspiciously resembling reality engine technical limitations. Take light speed, 299,792,458 m/s. In physical world, such rigid upper speed boundary seems arbitrary, but in computer simulation, it is absolutely necessary. This is maximum information transmission speed inside processor, maximum frame update frequency above which causal relationships begin crumbling. Light speed is our system's latency, ping that cannot be overcome. Next, we encounter quantum mechanics. At micro level, space and time stop being continuous. So-called Planck length exists about 1.6 Fe10 Fe meters. Below this distance, physical meaning is lost. This surprisingly resembles screen pixelation. We cannot infinitely magnify image. Sooner or later, we hit minimal graphic element size, reality pixel. Even stranger looks observer effect in quantum mechanics when particles remain in uncertainty until measured. In computer game terminology, this is called procedural generation or rendering optimization. Why render every star's interior or every room's details if no one's looking? System saves resources, creating reality, only when players' gaze directs at it. Universe informational nature is also confirmed by Bekenstein bound. This physical law determines maximum information quantity contained in limited space volume. Black holes are essentially densest hard drives in universe. If you try recording more data than event horizon area allows, system collapses. This is hard memory limitation of our world. In this context, searching extraterrestrial intelligence with radio telescopes looks hopeless. We try catching signal from neighboring galaxy. Not understanding galaxy is just background texture on celestial sphere. Astrophysicists studying cosmic background radiation possibly seek not Big Bang echo, but compilation artifacts. Program startup, moment traces. But why would someone create such grandiose illusion? Goals might vary from sociological scientific modeling to entertainment. Perhaps great filter we so fear not passing is simply game victory condition. On civilization reaches certain development level and understands its reality nature. Simulation reboots or shuts off. This hypothesis frightens with its solipsism. It devalues history, turning billions of people's suffering and achievements into code variables. If stars are just projection, our loneliness is also artificial. We're rat in maze that suddenly realized walls are made of cardboard and cheese is distributed on schedule. Somewhere beyond our understanding, experimenters' eyes watch us. However, even if we live in Matrix, for us this reality remains only one. Pain, love, and death fear are as real here as in base world. Simulation hypothesis doesn't remove responsibility. It only raises stakes. If we're part of experiment, our task is showing result worth keeping server running. We must prove we deserve occupying universe RAM. Chapter 15. The Cosmic Perspective. We've sorted through all variants. We sought them in present and past, in biology and physics, in distant space and reality code. Each answer generated new questions, but all led to same conclusion. Right now, this second, we're on our own. This brings us to our investigation's final, most important part. If no one will come save us and no one will come destroy us, then who are we and what should we do with this deafening freedom? This deafening freedom frightens more than any hostile fleet. If simulation hypothesis isn't true, if dark forest is just our paranoia and great filter is already behind us, we remain with heaviest fact of all possible. Look at this blue dot, all infinite blackness around that. We scanned with radars and telescopes is silent for one simple reason. No one's there. We've grown accustomed to seeking gods, elder brothers, or at least competitors in sky. We wanted believing someone wise already laid trails between stars, and we need only find their map. But data we've collected, 12 chapters straight, inexorably turns us toward mirror. What if we're not latecomers to galactic dinner? What if we're first, from universe chronology perspective? This is quite permissible. 13.8 billion years went to cooling plasma, lighting first stars, working heavy elements in supernovae furnaces, and assembling them into planets. We appeared just 200,000 years ago, 0.14% of cosmic age. We're consciousness's first flash in just awakened galaxy. Look at Earth's night side. This light network is only proof entropy can be reversed. Our global energy consumption today is about 18 terawatts. By Nikolai Kardashev's scale, we're not even type I civilization. We're somewhere at 0.73 mark. We still draw energy from dead plants, oil and coal, instead of controlling planetary climate. But exactly now, we're passing critical point astrophysicists call green filter. This is maturity test. Can mind that created planetary scale technologies not destroy its own biosphere? If we're alone, then Earth isn't just our home. It is only life arc within billions of light years radius. This arc has no backup crew. Paradoxically, the more technological we become, the harder we are to notice from space. In 20th century, we screamed into ether with powerful analog television broadcasts. Today we retreat into fiber optics and directed digital communication. Earth radio silence zone expands. We become invisible not because we hide like in dark forest hypothesis, but because efficiency demands quiet. Perhaps other civilizations aren't silent. They're just too efficient to make noise. However, while we haven't found anyone more efficient than us, this imposes on humanity responsibility that takes your breath away. Physics has no law requiring observer existence. Universe would exist perfectly well without us. Stars would be born and die. Black holes would warp space, but no one would appreciate this grandeur. Without us, universe is just giant mechanism working in darkness. We are its eyes. We're space's way of knowing itself. If we make fatal mistake, nuclear war, create uncontrolled artificial intelligence, or destroy ecosystem, reason light will extinguish not only here, but everywhere. Epilogue: the great responsibility. We often lament not seeing megastructures and stellar engineers. But look at your cities, at internet enveloping the planet, at satellites controlling weather. We're already building technosphere. We're those very ancients whose ruins, perhaps future civilizations, will seek eons from now. We stand at galactic history origins. We needn't seek mentors. We must become them. This changes our search vector itself. We no longer seek saviors. We seek expansion room. If galaxy is empty, it is not dead. It awaits. It is clean canvas ready to accept life. Those 6 billion Earth-like planets we discussed in second chapter now probably represent lifeless stones and oceans, but they can become gardens if we survive. Biocentrism asserts life isn't accidental mold on stone surface, but reality's central element. If we're consciousness's only carriers, then every human, every child, every scientist and artist carries particle of universe, meaning human life value in empty universe increases to infinity. We have no right to self-destruction because we belong not only to ourselves, but are we ready for this role? So far we behave like teenagers who inherited huge mansion and started fire in it. Our technology outpaces our morality. Doomsday clock shows 90 seconds to midnight. We learned splitting atoms before learning to live in peace with each other. This is main paradox. Universe's only civilization's greatest threat comes from itself. Nevertheless, hope exists. We're the only Earth species that created global asteroid defense system. We create Svalbard seed vault and lunar data arcs, trying to ensure evolution heritage. We begin understanding the planet is finite, painful growing up, but necessary. Space silence isn't disregard. It is strict examiner silence waiting for our answer. We traveled from single cells in primordial soup to beings capable of seeing cosmic background radiation and understanding its nature. This random chain is so incredible that repeating it would be practically impossible. We hold winning lottery ticket and simply must cash it. Loneliness isn't sentence. Loneliness is blank check. If no one within thousands of light years radius could hear our signal, then we have no one to fear except our own reflection. No zoo, no evil wardens, no galactic empire, will prohibit our space exit. Barriers exist only in our head and physics laws, which, as we know, can be circumvented but not violated. Look at this world once more: fragile biosphere, thin gas film held by gravity, and billions of minds trying to find answer to question, why are we here? Perhaps answer is simple. We're here to carry life further, so millions of years from now, on those very empty exoplanets James Webb Telescope currently sees, someone looked at sky and said, we're not alone because our ancestors came from Earth. We complete our investigation not with period, but ellipsis, all evidence collected. Witnesses from quantum physicists to evolutionary biologists gave testimony. We examined variants where they kill us, ignore us, and where they simply don't exist. But reality, whatever it may be, demands action from us. Universe silence is invitation to conversation. We must begin first. We stand on cosmic ocean shore. Water is cold, dark, deep, but we cannot stay eternally on beach-building sandcastles that time tide washes away. Time has come to learn swimming because ultimately two possibilities exist. Either we're doomed to disappear here or we're doomed to populate stars. There is no third option. We began this journey with simple question. A child asks looking at night sky, where is everyone? 120 minutes ago, we stood at Raton -600 radio telescope foot, deafened by white noise. We sought signal in radio range, sought Dyson sphere thermal traces in WISE telescope data, sought chemical anomalies in exoplanet atmospheres with James Webb Telescope. We disassembled universe into atoms, sifted data through statistics and thermodynamic sieve. Now, standing at this path's end, we're forced to acknowledge heavy but sobering fact. Sky is silent. This silence isn't technical error or equipment malfunction. This is fundamental property of reality we observe. Arthur C. Clarke once formulated dilemma that became our search epigraph. Two possibilities exist. Either we're alone in universe or we're not. Both are equally terrifying. If we're not alone, then dark forest hypothesis is true. We're careless victims screaming in jungle full of predators whose technologies advance millions of years ahead of ours. In this scenario, silence is sound of hidden threat, but second possibility frightens much stronger. If we're alone, then Earth isn't just ordinary planet by ordinary star. As Copernican principle claimed, this is arc. This is only place within 46.5 billion light years radius where matter acquired ability to feel, love, and know itself. In this case, we're not just biological species. We're universe's way of realizing its existence. Without us, these gigantic spaces are just dead scenery. Theater without audience and actors, where stars burn wastefully, birthing no meanings. We passed through evolution's narrow bottleneck. We overcame filters that screened out billions other potential civilizations. Random complex cell appearance, Ice Age survival, 20th century nuclear crisis overcoming. Each these events had probability approaching zero. The fact you now hear these words is statistical anomaly of incredible scale. We're survivor bias that gained reason, and this imposes responsibility whose weight compares to black hole gravity. Look at Helix Nebula, at this God's eye gazing at us from abyss. It consists of same gas and dust as our bodies. But between us exists one critical difference. Stars obey thermodynamics' second law. They tend toward chaos and decay. Life is only known force moving in reverse direction. We create order from chaos. where matter's local rebellion against entropy. If this fire extinguishes here on Earth, universe might remain forever cold and dark. Fermi paradox stops being paradox if we accept first hypothesis. Perhaps ancient civilizations didn't disappear. They simply haven't happened yet. Perhaps we're those very ancients whose ruins will be sought by other races' archaeologists in 5 billion years. We're galaxy's first attempt to light reason. This explains silence. No one flew to us because there is no one to fly. Space roads aren't built, maps aren't drawn. We must do this ourselves. This perspective changes everything. Our internal conflicts, resource wars, ecological myopia, all stop being local problems of one primate species. This is threat to reason existence as such. If we destroy ourselves, we won't just commit suicide. We'll commit cosmic crime, extinguishing only candle in infinite temple. Great filter isn't behind, it is right before us. Its name is our own immaturity. We already see first steps toward leaving cradle. Mars rovers on red planet surface, lunar base plans, generation ship projects. This isn't science fiction, but evolutionary imperative. To survive, we must become multiplanetary species. Not for conquest, but backup. Kepler telescope data showed us billions of worlds awaiting their hour. They're empty, not because they're cursed, but because they await us. Our investigation showed no guarantees exist. Universe is indifferent to our fate. Asteroid, gamma burst, or our own stupidity can erase us in an instant. And no one will come to help. In this infinite black ocean, there are no lifeguards. We're alone in boat. This absolute cosmic loneliness should become foundation, uniting us stronger than any ideology or religion. Extraterrestrial intelligence search is noblest of all scientific tasks because it forces us to mature. Even negative result is priceless knowledge. It tells us, cherish Earth. There is no other home, and neighbors to borrow salt from don't exist either. We continue scanning sky. We build new telescopes, we listen to silence. And if you, like us, feel this infinity call, stay with us in this search. Your support and interest is fuel, allowing us to continue asking being's main questions. Perhaps someday, through thousands of years, ship with our descendants will enter distant exoplanet orbit in TRAPPIST-1 system. They'll descend to surface, breathe alien air, and look at night sky where sun will be just dim star invisible to eye. At that moment, Fermi Paradox will be resolved because aliens will be us. Until then, only silence hangs above us. Magnificent, frightening, ringing silence. Don't fear it. Listen to it, because in this silence sounds not life absence but space for our future. Universe is silent because it holds breath, waiting for what we'll say.